this video we will see how to apply the concept of superposition of forces on electrostatic forces in 2 dimensions, and it will be focused on forces at right angles. We have this example. Find the net electrostatic force acting on QB. This is QB, the force that is at right angle in this triangle. So at QB, we have 2 forces, which are the force applied by A on B and the force applied by C on B. So first I will cover QC, and I will think this way. A and B are unlike charges, so they attract each other. So the effect of A, or the force applied by A on B, is a force of attraction, which means that A will pull B this way. This is the force by A on B. Then I will cover QA. The same thing. C and B are unlike charges, so they attract each other. Then, since I'm studying the forces on B, I will say the force applied by C on B is an attractive force that pulls QB towards QC. So this will be FCB. Then I have to calculate each force. FAB is equal to KC, Coulomb's constant, QA, QB over RAB squared. We replace the values. Do not forget to convert from microcoulombs to coulombs. From microcoulombs to coulombs, you multiply by 10 to the power of negative 6. So QA is negative 2 times 10 to the power of negative 6 coulombs. QB is 4 times 10 to the power of negative 6 coulombs. And the answer is 8 times 10 to the power of negative 3. Then we find the force applied by C on B, which is FCB, that is equal to KC, QC, QB over RCB squared. We replace the values. QC is negative 6 times 10 to the power of negative 6 coulombs. QB is 4 10 to the power of negative 6 coulombs. And K is constant. The distance from C to B is 4. The answer will be 0.0135 newtons. Now, we found each force. We need to find the net force or the resultant force. As you see, FAB and FCB are perpendicular to each other. They form a right angle. Then their resultant is found using the Pythagorean theorem. Why? The diagonal from this point to this point, if I continue drawing the rectangle like this diagonal is equal to this diagonal in magnitude. So the resultant, which is F net, is found by finding the magnitude of the other diagonal using the Pythagorean theorem. So F net is equal to FAB squared plus FCB squared. We replace to get the final answer for F net as 0.0157 newtons. We're done finding the magnitude of F net. We still have to find its direction. Okay, to find the direction, we have to find the reference angle from the positive x front going counterclockwise. I will choose this angle, this one. So theta is equal to tan inverse opposite over adjacent. If I use this triangle, this one, I will say this is the angle theta and this side is opposite to theta. The length of this side is equal to the length of FAB. So the opposite to this angle is FAB and the adjacent is FCB. We replace their values, the values that we found, and we find the angle. It will be 30.65 degrees. We calculated the angle but not the reference angle. This angle is in quadrant 1 above the x-axis. So the reference angle, which is this one, is equal to, we start from 0 plus theta, so 0 plus 30.65 degrees, and we get 30.65 degrees from the positive x front. Another exercise about the same concept. We have a system of 3 charges. We have to find the net electrostatic force at charge QB, at this one. So, same thing. Let's start by covering QC. A and B are like charges, so they repel. So A will repel B and B will repel A, but since we are studying the effect on B, then we draw the force that only acts on B. So A will push B away or will repel B away in this direction. Now we cover QA. C and B are both negative, they are like charges, so they repel. Then C will push B away in this direction. We calculate each force the same way. KCQAQB over RAC squared. We replace the values and we find FAB. Then we do the same thing for FCB and we find the answer. Now to find Fnet, if you look at FCB and FAB, they are perpendicular to each other or they are forming a right angle. So to find their resultant or their net, you use the Pythagorean. As you see, this is, we extend the lines, we draw a line parallel to the x-axis and a line parallel to the y-axis to draw the net electrostatic force. This is Fnet. And then we use this formula. Fnet is equal to FAB squared plus FCB squared. We replace the values and we find Fnet. Next step, to find the direction. The same way, theta equals tan inverse opposite over adjacent. I will consider this angle. I can't choose this one. I will comment on this at the end of this exercise. So the opposite to this angle is this side, this dashed line, which is the same as FAB. And the adjacent is FCB. We replace the values and we get the answer as 10.62 degrees. Now, this angle, if I consider that this is the x-axis, the reference angle is this one, this red curve. So the reference angle is equal to this part, which is 180. So from this point to this point it's 180, and then we add the angle theta, so it will be 190.62 degrees from the positive x front. Okay, what if I chose this angle? The opposite will be FCB, the adjacent will be FAB, the angle will be of a value of 79.38, and then the reference angle will be 270 minus this angle. It will give you the same answer, which is 190.62. Okay, a third example with 3 negatively charged objects, A, B, and C. Find the net electrostatic force acting at B. We do the same exact thing. We cover QC. FAB is to the right because A repels B. Then we uncover C and we cover A. FCB is also a repulsive force, so C will repel B this way. We calculate each force. We replace the values, and then for Fnet, since the forces are perpendicular to each other, again we do the same thing. We draw a line parallel to the y-axis, a line parallel to the x-axis. We draw this vector Fnet. To find it, we use this formula and we calculate its magnitude. Next step is to find the direction. Theta equals tan inverse opposite over adjacent. I chose this angle, so theta equals tan inverse. This is the opposite side, which is the same as FAB, and the adjacent is FCB. We replace to get the values. Now the reference angle will be this one. It will be this angle, which is 270 plus theta, and we find the answer as 300.65 degrees from the positive x front. Or you can do the other angle. You can find this angle, and then the direction will be the whole thing, which is 360 degrees minus this angle. You will get the same exact answer. A fourth example where we have three charges, B, C, and A, and find the net electrostatic force at QC. First we cover this one, then we find FAC, which is a third example with three negatively charged objects, A, B, and C. Find the net electrostatic force acting at B. We do the same exact thing. We cover QC. FAB is to the right because A repels B. Then we uncover C and we cover A. FCB is also a repulsive force, so C will repel B this way. We calculate each force. We replace the values, and then for F net, since the forces are perpendicular to each other, again we do the same thing. We draw a line parallel to the y-axis, a line parallel to the x-axis. We draw this vector F net. To find it, we use this formula and we calculate its magnitude. Next step is to find the direction. Theta equals tan inverse opposite over adjacent. I chose this angle, so theta equals tan inverse. This is the opposite side, which is the same as FAB, and the adjacent is FCB. We replace to get the values. Now the reference angle will be this one. It will be this angle, which is 270 plus theta, and we find the answer as 300.65 degrees from the positive x front. Or you can do the other angle. You can find this angle, and then the direction will be the whole thing, which is 360 degrees minus this angle. You will get the same exact answer. A third example, a fourth example where we have three charges, B, C, and A, and find the net electrostatic force at QC. First we cover this one, then we find FAC, which is a repelling force. A repels C up. Then we uncover B and we cover A. B will attract C, so B will pull C this way. This is FBC. We find FAC the same way as we did in the previous examples. FBC, a repelling force, it repels A. And then FBC, KC QB QC over RBC squared. KC is 9 10 to the power of 9. QB is given as 4 microcoulombs. We convert it to coulombs. QC is negative 6 10 to the power of negative 6 coulombs over 4 squared. We find the answer. Same thing, the forces FBC and FAC are perpendicular to each other. We draw the lines parallel to the x-axis and the y-axis, and we draw the net or the resultant force, which is F net. To calculate it, we use Pythagorean, and we find the answer. Then for the direction, tan inverse opposite over adjacent, I will choose this angle. The opposite side is this one, which is the same as FAC. The adjacent is FBC. So it's tan inverse FAC over FBC. We replace we get the answer. Now for this angle, the direction is from the positive x front to the vector, which is 90 plus the angle, so 90 plus the angle, or it will be 180 minus the angle that we found. So to find the direction, it will be 180 minus this angle, and we find the direction as 138.37 degrees from the positive x front. Another example, we have three charges, QB, QA, and QC. We cover QC, we will say that A repels B away, so it pushes it up. And then we cover A, and C pushes or repels B to the left. So we did the drawing for FAB and FCB. We calculate FAB, we replace the values. We calculate FCB, we replace the values of the givens. And then we draw the lines parallel to the y-axis, parallel to the x-axis, and Fnet. To find it, we use Fnet equals square root of FAB squared plus FCB squared. We find the magnitude of Fnet. Then to find the direction, tan inverse opposite over adjacent, I chose this angle, which is theta. Its opposite is this side, which is FCB. The adjacent is FAB. So we replace to get the answer. Then the direction will be 90 plus this angle. We measure it from the positive x-axis and we go counterclockwise. So we have 90 degrees plus theta. We get this answer, 120.65 degrees from the positive x front. Another example where we have two negatively charged objects and one positively charged object. We have to find the net electrostatic force acting on QC. We're talking about this charged object. So we have to find the forces by A on C and the force by B on C. We hide QB, and FAC, A and C are unlike charges. They will attract each other. Since I'm studying the effect on C, then I will say A will pull or attract C upwards this way, FAC. Then we uncover B and we cover A. B attracts C as well, since they are unlike charges, and we're finding the net force on C, so this is FBC. Next step is to calculate FAC the same way as we did in the previous examples. FBC, same thing. Then we have to find the net force. We draw a line parallel to the x-axis, a line parallel to the y-axis. We draw the net force, and to find it we use the Pythagorean. We replace to find the answer. Now for the direction, tan inverse opposite over adjacent. I chose this angle. The opposite is this red line, which is the same as FBC. The adjacent is FAC. We replace, we find the answer as 59.35. This is the angle theta. It's not the reference angle or the direction. The direction or the reference angle is this part, is this one. So to find it, I will say from this point to this point is 90 degrees. If I remove theta, I will get the reference angle. So the direction is 90 minus 59.35 degrees, which is 30.65 degrees from the positive x front.